Welcome to Math with Professor V. This is video lecture for section 1.3 on slopes and three forms for lines from the video series Bridging the Gap from Precalculus to Calculus. Now, the slope of a line between 2 points, x1, y1, and x2, y2 is a number representing the ratio of the change in the y direction and the change in the x direction. So say you have a line and you have 2 points on the line. Here's x1, y1, x2, y2. Notice that for any point x, y on the line, if you pick a third point, we form two similar triangles. So we have this larger triangle here, which I've represented right here to the left. And then we have this smaller triangle right here. And remember, when we have a triangle sitting inside of a larger one, we have similar triangles, which tells us in that scenario that the ratio of the height over the base is always constant. So the ratio of the height of this triangle over the height of this triangle equals the ratio of the base of this triangle over the base of this one. So this constant, this ratio is the slope of the line. It basically is measuring the steepness of the line. It tells you how steep the ramp is. So you can imagine you're on a treadmill. Incline 0 is flat. Incline, the most they crank them to at the gym I go to is 15, okay? And then if you had a negative slope, then the direction would be going downward. You'd be going downhill. So you're walking this way. You are walking this way. Bigger slope, bigger positive slope, steeper ramp, okay? Think of it like that. Now, since this xy was arbitrary, we know that this slope is constant for all of the points on the line. And if you just rearrange, here's this, and you rearrange and multiply over x2 minus x1 to the other side, you get point slope form. This is the most useful form when you're asked to write the equation of a line. That's the one you should go to by default. Now, if the point x1, y1 happens to be of the form 0, b, b is the y-intercept, then this form, this equation simplifies to slope-intercept form, which is probably more familiar to most people, y equals mx plus b. And most of the time when we write the equation of a line, we put it in slope-intercept form, okay? But to get the ball rolling, I go to point slope form. That's where it's at. Now these two, along with general form, which we've talked about earlier, give us the three different ways to describe a line. And each of them has their own advantages and disadvantages. So you need to know how to work with all three forms, okay? Very good. So let's look at some examples now. Put each line below into slope-intercept form. Which one is that? That's y equals mx plus b, if possible, and sketch its graph. So we're asked to find the line containing the points -3, 2, and 1, -2. So the first thing we need to do is find the slope, okay? Find the slope, and then you're going to jump straight to point slope form. Y minus y1 equals m times x minus x1. Okay, I would say start off, label the points x1, y1. x2, y2. The students mess up by jumbling that around. That's the most common mistake I see. So m equals, you just need to remember this, y2 minus y1 over x2 minus x1. And it doesn't matter which one's x1, y1, which one's x2, y2, just be consistent throughout the problem. So y2 minus y1, that's going to be -2 minus 2 over 1 minus -3. So here we've got -4 over +4, very good, which simplifies to -1. So now I have m, this is my m for point slope form, and then I'm going to replace x1 and y1. You can actually use either point. You could use this one or this one. It doesn't matter that we called this one x2, y2. But the x and y that have no subscript, you leave them as x and y in the equation, okay? So I'm going to have, let's just use this guy. Y minus y1 is 2 equals m, which is -1, times x minus x1, which is going to become x plus 3. Now, this is point slope form, but they want slope-intercept form, so I'm going to multiply everything out. So we have y minus 2 equals -x minus 3 So y equals negative x minus 1. Very good. Now they do want us to graph, and you have a couple options because notice with this problem, they gave us 2 points to start off with, right? So I could literally just plot those 2 points and be done. But we did that in the whole last section, so I want to show you a different way. When we have our line in slope-intercept form, this is the slope. It tells us rise over run. And then B, the y-intercept, tells us that the graph goes through 0, b. So what does this tell me here? B is negative 1. So the y-intercept is negative 1. So a point on the graph is 0, negative 1 right here. And then the slope is negative 1. We have negative x. So you could think of it as negative 1 over 1. So you're going to rise negative 1, run positive 1. That way. Rise negative 1 means go down 1, run 1. Alternatively, you could think of it as 1 over negative 1, meaning you rise positive 1, you run negative 1. It doesn't matter. You see how they're all lining up? Yes, Professor V. So there you go. However you want to slice and dice it. And then if you were to keep going, negative 3, 2, and 1, negative 2 would also be on this line. Okay? Good. Let's look at another example here. The line containing 5 halves, 3 halves, and negative 1/3, negative 4/3. So same process, just uglier numbers. Find the slope first. This is x1, y1, x2, y2. So my slope m is going to be y2 minus y1, so negative 4/3 minus 3 halves, over x2 minus x1, so negative 1/3 minus 5 halves. Now this is just truly disgusting. So what I would do if I was you is I would multiply everybody through by 6. Why did I pick 6? Because the denominators are 3 and 2, and it would get them all to cancel out. And this distributes, So that'll give me negative 8 minus 9 up top over negative 1/3 times 6, that's going to be negative 2, minus, that's going to give me negative 5 halves times 6, 15. And notice up top we've got negative 17 over negative 17. Oh my God, it's just positive 1. The negatives cancel out. What a lovely little slope. I thought things were going to be worse. Okay, now we go to point slope form. Remember, y minus y1 equals m times x minus x1. So y minus, let me just use the 3 halves right there, equals m is 1 times x minus 5 halves. So what does this give us? Y minus 3 halves equals x minus 5 halves. Add 3 halves to both sides, I get y equals x minus 1. Boom. And see, I'd much rather just plot the slope and the y-intercept than these nasty little fractions. So the slope is 1, which we're going to think of as 1 over 1. And the y-intercept is the point 0, negative 1, since b is negative 1. And with those two, we're going to be on our merry little way. Always plot the y-intercept first. So I'm going to plot 0, negative 1 first. And then from there, I'm going to go up 1, rise 1, run 1. Okay? And you could do it again and again and again if you need, but 2 points is enough. 2 points uniquely define a line into space. Okay? Very good. Now, a little bit of terminology. We say that 2 lines are parallel if they have the same slope. So find the equation of the line containing the point 4, negative 5, and it's parallel to y equals 4x plus 3. So let me ask you this. Can you tell me what the slope of the line y equals 4x plus 3 is? Very good. It's 4, right? M is 4, whatever coefficient is there on x. So m is 4, and then this is your x1, this is your y1. So now let's put it into point slope form. Y minus y1 equals m times x minus x1. Good. Now you call the cleanup crew. Y plus 5 is 4x minus 16. Subtract the 5, so y is 4x minus 21. There you go. So the y-intercept is negative 21. 0, negative 21. And the slope is 4. So you could count rise over run from here. Also, we know our line contains the point 4, negative 5. And you might say, oh my goodness, Professor V, I'm stressing. I have to go all the way down to negative 21. Yeah, but we're going to do it slick. We're going to count by 5s, okay? So we'll say this is negative 5, 10, 15, 20, okay? And then nobody said the x-axis has to be scaled the same way. So this will be like 1, 2, you get it? You do what you want. It is your graph. You live your best life. So here we go. 0, negative 21, boom, right there. I also would like to graph 4, negative 5. Remember, this is scaled by 5s. So 4, negative 5 is going to be right here. Okay. And then you just move on with your life and you go, I'm not stressed. Look at it. We scaled so elegantly. Beautiful. Now, if someone didn't scale by 5s, their graph would look a little steeper. Okay. It's all good. It's all good. Next one. The line containing negative 2/3, 1/2 that is parallel to 5x minus 3y equals 8. Ooh, so look how mean they were this time. You see how like we could look at this equation, bam, we knew the slope was 4 because y was by itself. It was in y equals mx plus b form. That's not happening here. So first we have to get y by itself for us to figure out what the slope is for this line. So subtract over the 5x. And then now divide by negative 3, so y equals 5/3 x minus 8/3. So I can tell right now the slope is 5/3. And then here's the point x1, y1 that we're going to use for point slope form, okay? So y minus 1/2 equals m times x minus negative 2/3, which is x plus 2/3. Okay. I'll let you practice cleaning it up. We get y equals 5/3 x plus, that would be 10 over 9 plus 1/2. So then we're going to end up with 29 over 18. Okay. Kind of disgusting, but it's correct. So here the slope is 5/3, rise over run is 5/3. And the y-intercept is 0, 29 over 18, which is a wee bit less than 2. I just think to myself, 36 over 18 would be 2. This is less than that. It's obviously more than 18 over 18, though, so it's bigger than 1. And the slope is 5/3. Okay, so 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. So 0, 29 over 18, I'm going to say it's there. And then the slope is 5/3, so I'm going to go up 5 over 3. So up 1, 2, 3, 4, 5 over 1, 2, 3, somewhere around there is the second point. I'm really just eyeballing, okay? Because with these fractions, what do they want from me? I'm doing the best I can. Very good. Okay. 2 more sweet little examples. The line containing 1, 4 parallel to x equals 2/5. So remember, in the last lesson, we learned that if you have just x equals some constant, that's a vertical line. Okay? These ones I think are easier to solve just by graphing. So they want our line to go through the point 1, 4. And if they're telling me it's parallel to x equals 2/5, that means it's also vertical. So let's plot the point 1, 4. Here it is. Draw a vertical line through that point. Okay, here we go. Is that what you want, Professor V? Yeah, that's what the problem wanted. So what's the equation of this line? It's going to be x equals something. X equals whatever the x coordinate was in the point that they gave us. That's literally all there is to it. And you can't put this in slope-intercept form. You can't put this in y equals mx plus b form because there's no y. So that won't work. Okay, let's try another one. I'm sure that this is making you nervous. the line containing 2, -4 parallel to y equals 17. Well, y equals 17 is a horizontal line when you have y equals whatever, right? So now let's draw the point 2, -4, 2, 1, 2, 3, 4, -4. The point would be right here. If it's parallel to y equals 17, it's going to be horizontal, okay? Well, this time the equation would just be y equals -4, whatever the y coordinate was of the point that we were given. Because every single point on this line has a y coordinate of -4, and the x can be whatever. All right, don't worry, there's plenty more like this that you can practice in the homework. So that concludes the lesson. And then in the next section, we're going to go over how to solve linear inequalities. Don't forget to subscribe, give the video a thumbs up, and if you need any more help, you can check out the other video lectures I have all organized into playlists on my YouTube channel.